My name is Apar Singh. I'm part of Agilent Technologies. I'm an IT architect. I'll be speaking today on our experiences with in-memory data grid systems, and I'll also be sharing some thoughts about how we can utilize in-memory data grid systems on especially digital systems that different organizations have. Before I get started, I'd like to say I'm happy to answer any questions. If you guys want to pause me in the middle of the presentation, that's completely okay with me. And I'll be also available outside to chit-chat about your questions later after the session. Right, let's get started. Let's talk about a little bit about Agilent Technologies if people in the room don't know about it. Agilent is a leader in life sciences, diagnostics, and applied chemical materials. It's been was a spin-off from HP in 1999, and we've been really working in these 6 major markets, including diagnostics, pharmaceuticals, research, environmental and forensics, chemical and energy, and food. So you can see, the portfolio of products that we have across these industry verticals are really it spans across industries. Plus, by the look of the industries, you might have imagined that we are also in a really highly regulated space. So any data that we have, it's highly regulated by FDAs and other organizations, including corresponding FDA organizations across the world as well, not only in US. So we invest heavily in research for our instruments and softwares, which help customers diagnose their problems much faster, whether those are laboratories or whether those are doctors who are helping patients treat diseases like cancer faster. So, that's our portfolio. I'll be covering today few use cases that we thought makes a very good fit for in-memory data grid systems, including how do we build a system which helps us to have a flexible data and connect that data with our downstream digital applications, including our e-commerce store, including our customer experience platform, like a major CMS system in the market. And I'll also be talking about how to improve your time to market for products. We all know that there's challenges with pushing new product changes over to the customers, and how can we improve that, and what role does the in-memory data grid systems play with the time to market for products. I'll also be talking about some digital data touchpoints. What are the touchpoints for businesses when they interact with data, and how can we make sure that we build a completely integrated system which works across the multiple business processes across these multiple touch points for data. So I'll be talking about that a little bit. I also talk about normalized data catalogs, the pros and cons for having normalized data catalogs versus what are the challenges for them for downstream applications like the e-commerce store or the online web. I'll also talk about how do we solve some of these problems later by talking about in-memory data grid implementations and the skinny integrations that we build. We'll then talk about the access of normalized data and how do we make that perform better. And then, of course, we'll talk about the high-level architecture and a couple of our use cases where we used in-memory data grid, including a recommendation engine which we built for the web. That's a summary of what we're going to look at. Let's get started. We will start with agility and data flexibility. A couple of terms that may make sense or not, but as we go through, we'll talk about them. Agility of a digital team is one of the key measures in organizations today. Whether you can churn out things faster for your customers or not, it really creates an edge for you with your competition, especially in the digital age. If you look at the chart, and that's a generic chart from the industry, if you look at that, IT budgets are almost flat over the years. And those budgets grow incrementally 1% every year, right? But if you look at the chart, which also talks about IT's ability to deliver, as we add more resources and capabilities and infrastructure into our systems, that does grow every year. So growth rates is somewhere close to 10% every year with those flatlining budgets. But on the other side, if you look at business needs and business expectations, those grow exponentially every year. And there's always this race going on to figure out how do we solve the time to market problem for newer capabilities? How do we solve time to market problem for new product introductions? And while having static budgets and while having incremental growth to your IT capabilities. So one of the bigger edge that you can have over competition is to have better time to markets for your new products and capabilities. We'll talk about how to get there. This was the major problem that we wanted to solve. The other problem that we were facing was also data flexibility and its complexity. As I talked about the Agilent's portfolio and the industries that we work with, the product set that we offer are very complex, very technical in nature. They are highly regulated. So to give an example, we cannot really market a product unless we go through regulatory approvals from FDA and other industries. And in order to market a product, we have to get the marketing language approved from them as well to make sure because all these products affect human health, affect major industries across the world which are linked to human health. It becomes very important for us to have the right disclaimers, the right regulatory checks across our digital systems to make sure that we are presenting information that has been completely approved by FDA, which also not only approved by FDA, but also meets Agilent standards. So this means a lot of complexity in our systems, and also a lot of complexity in the amount of data that we store and the attribution of the data. So how do we solve it? So one of the ways that we thought of figuring this out is by looking at data flexibility. So we said, well, if we could figure out a way to integrate our product data models in a very normalized way with our downstream applications, business can continue to add new products with newer attributions in every release. So Agilent acquires multiple companies in a year, and what that also means is getting new product portfolios introduced in our organization. Now, in order to get those product portfolios into our organization and in our MDM systems, master data management systems, we also need to make sure we are able to scale our data models with those new product lines. And that builds this challenge for us to make sure the data models can keep on improving, keep on growing on a quarterly basis when we introduce new product lines. But also, we don't have to play a catch and mouse game on our web or on the e-store so that we keep changing our data models internally on the web or e-store when there are challenges or when there are new products that get introduced. So it was a big problem for us, and we wanted to see how we can solve them. The chart kind of talks about, on an average, how much effort we spend in every release. And if you look at it, data model changes kind of spans around 30% of the amount of effort that goes in on every release. Every release, there's some new product portfolio that we are trying to integrate. That product needs newer attribution, newer kinds of data models. And not only we have to do those changes on our master data management system, but also on our downstream applications, which are consuming that master data coming in, whether that's our e-commerce store or whether that's on our Agilent.com web. So we wanted to stop this catch and mouse game. We wanted to figure out a way to, how do we solve for this problem? So normalization, as you all know, normalized data is probably the most flexible data available out there. If you can figure out what are your entities, you could figure out how to essentially not keep changing those entities as you go along and add new products. But again, normalized data has its own problems, and we'll talk about them a little bit. Yeah, so the second problem we wanted to solve was the data flexibility. So before we started this endeavor, we had multiple touch points for business across our digital platforms. The slide talks about multiple systems that we had in our portfolio, starting from the bottom. Those are our data sources. There's ERP and CRM systems, product data management system or MDM, our digital asset management system, which holds all the digital assets across our digital domains. And then they integrate with our downstream applications, including a CXM platform, which helps us to run our site, including a search index, which helps us to provide search for our customers internally, and including an e-commerce store, which also provides the online checkout capabilities that we have. Now, if you look at the digital touch points for business got to go in and update data in ERP first. That's where all the product lines get started. That data comes over to MDM for enrichment for the downstream applications. And also, they have to go into digital asset management system in order for them to create digital assets like documents, videos, images that are much needed across the web to ensure that we can market our products correctly. The other touch points are really CXM. You have to go in for making sure that you can build promotions for your marketing your newer products. So that's another touch point for business. E-commerce store, that's where you are entitling products. So as I said, we're in a very big regulatory space. We have to figure out a way on our e-commerce store not to sell certain products in very critical markets, or whether to sell them or not. And those entitlements are maintained in our e-commerce store. And that's another touch point for our business. The other touch point being our search indexes, where if they have to boost or bury some new search results, they go into our search indexes and make sure that they can boost and bury some new search results. So a new product comes up, and everybody wants that to show up on the search results, on top of the search results on Agilent.com. And that's another touch point for business to make sure they can boost those results for a new product. So it's a pretty complex business process for our internal businesses. And we had to figure out a way to build integrations around this business process of going into ERP, going into MDMs, going into digital asset management systems, going into CXM, e-stores, and search indexes. You can't skip any of those steps if you want to make sure that there's high level of visibility for your new products which are coming up. So it's a pretty complex business process. Now, sure, you can build a separate system called BPMs where you can manage your business process, but you also have to ensure that your integrations, which are integrating your data sources with the downstream applications, those integrations are revolving across this whole business process that the business has to update the content. Plus, we also want to make sure my CXM platform and my e-store doesn't keep on chasing the data model changes on my MDM or ERPs or digital asset models. So that was one of the problems. So we talked about that problem. These were the time to market SLAs that we had earlier. Well, if you look at them, they're telling you how much amount of time each of these areas need for making a product live. For example, if you talk about marketing updates, so business comes in and says, I want to essentially add new images or new videos on an already available product on the web. The amount of time which they used to take for making those changes live were somewhere close to 5 to 6 hours with the integrations that we just saw. If you talk about product enrichments, it used to take them much more time to do it just because of how the systems were integrating. New product introductions, they used to take quite a lot of time. And that 10 hours is even a little bit optimistic. It used to take, when business had data ready in all their data sources, it used to take around 10 hours for the data to simply go live, just because of the integrations that we had. Support material additions is another example. So we had to talk to businesses to understand these problems and say, how do we improve the time to market of data and any changes that they do in MDM systems or the core data sources that we have across Agilent. Now, this gives me a good point to transition to talking about another problem that we had, which was normalized data. We talked about this a little bit earlier, but just to kind of emphasize on the complexity, a simple product catalog looks something like this on any organization, really, right? You got a product entity, you got a classification where you have to classify those products, right? What we call as catalogs as well. You might have multiple parts under a product, and that's another entity. You might have multiple attribute groups that go to different set of products. So a product like iPhone will have separate attribute groups than a product like MacBook, because, you know, the specifications of a MacBook are pretty different than specifications of an iPhone. So what we do about them is we said, okay, we built something called as attribute groups. So iPhone has its own specification attribute group, and MacBooks have their own. So that's another entity that you have to work with, right? Digital assets, every product needs some digital assets attached to them if you have to enable them or make them visible on the web or your e-commerce store. Marketing assets, that's another thing. Promotions and e-seminars, information about features of those products, all of those come under marketing assets. Support content, you really cannot have a product going live without providing support for it. So whether there's information about warranties of the product, whether there's information about how much data, how much processing that the product can do after getting installed on the customer side, all of those comes under support content. And that's another thing that is an entity on my product catalog. Specifications, as I said, these are simple attributes that define the product itself, whether you say what kind of hardware an iPhone has, whether that's have 256 gigabytes of memory or 128 gigabytes of memory. It talks about those kinds of attribute of a product. And then, of course, the regular attributes itself. So, if you look at the catalog itself for any organization, there's multiple entities that you have to work with. Now, we talked about entities, but let's talk about a simple data fetch for this catalog. Now, on the web, if you look at on the left and right, there's a simple pages on the web. In order to build a simple page, you've got to interact with each and individual, all these entities that are presented on the screen. A product page will need to fetch digital assets. A product page will need to fetch classification of the product so that you can build your breadcrumbs on your page. A product page will also need all the attributes so that you can show them in those specifications table. Product page will also need features of the product and also support information, which can probably come in the literature section. And also, of course, all the marketing information that the product page needs. It also needs parts. They are representative in this table. A product can have multiple parts, and that's something that you also need for a product page to fetch. So if we simply think about this simple example of, I need to build a product page. That means you've got to interact and fetch all these entities in your product catalog, and that's not easy. That means a lot of processing for rendering a simple page. That was one of the problems with normalized data. Normalization is great when you're trying to integrate with systems, but normalizations may or may not make sense when you're trying to access that data, which is completely sitting in a normalized fashion. Not a unique problem to us, but it was unique in the sense that our entities were much more complex than any other regular products like iPhones and MacBooks. All right, so what we could do, right? What if we could accelerate time to market for our products? That was, with multiple discussions with business, this came up. How do we improve products going live, product changes going live? with all the downstream applications that we host. Avoid chasing MDM data model for downstream. You come in, you say, there's a new product. I want to add another attribute to the product. Now, what we had to do was we had to add that attribute to our CMS. We had to add that attribute to our e-commerce store. We had to add that attribute on our search indexes. And that's like chasing the data model changes that happen in my product information management system or my MDM system. That took out a lot of velocity out of our development assets. And that's why the earlier chart, which represented 30% of our effort, went into data model changes for downstream applications. That's not productive. We can utilize that to do innovation. That was the idea. What if we could dynamically upgrade experience for newer products? One of the biggest goals of this project was making sure that we can dynamically upgrade. We can focus on experience of the customer rather than chasing data models, which are simply because of new product introductions or merger and acquisitions that Agilent does for other companies. That was another major goal of this project, making sure that we're not spending a lot of time on figuring out new product changes. Another goal was avoid spending times in integrations with MDM repeatedly. As I said, every release had the need for updating integrations. That was not productive. And focus on customer innovation and data-driven experience. Everybody talks about data-driven experience, but what does it really mean? It really means that once you have new set of product lines which start showing up on the web, you're able to adapt for those new product lines automatically without changing the experience or your front-end templates itself. And we wanted to focus on them versus we wanted to focus on customer personalization, how do we convert more on the web rather than just simply chasing MDM data models. So what if we could do all that? That brings me to the next section, which was leveraging skinny integrations and in-memory data grid systems. We talked about some of the problems that we had internally, and now we're going to talk about what we thought will be possible solutions. Leveraging skinny integrations. What does skinny integrations really mean? It's a term, right? Everybody can use that term with whatever they want. But how we use it is we say, well, does all the data really needs to be in all these downstream applications? So you got an MDM system, and that MDM is publishing data models downstream. And it's sending all the product data that it has downstream. But does the CMS really need all the data to be imported inside? Or does the e-commerce store really need that data to be imported? And the answer that we figured out was really no. So as the image suggests, the CMS is saying, I just need the reference of the data so that I know that the product exists somewhere. I don't need the data to be imported. We had around 1,500 attributes on a single product. That means a single product used to take somewhere close to 2 minutes to get imported, because you're not only looking at those 1,500 attributes, you're also looking at relationship of that product with images, with videos, with your documents, with all those things. Not a unique problem to Agilent, but again, it was the complexity of our data models that made us to this point. So do we really need those 1,500 attributes to be imported? And when we asked that question to ourselves, the answer was no. We started thinking about something called skinny integrations, which means that MDM is going to send references to these downstream applications, including a CMS system, e-commerce store, and the search engine, which is not representative in this diagram because it's talking to the CMS and e-commerce store. But the direct integrations were really for the e-commerce store. So they need just the reference. They need to know the essence of the product, if the product exists or not. That's what they need in order to build the experience. They can fetch pretty much everything else from somewhere else. That's what we thought. And so we started with a concept called core attributes. Core attributes are absolutely the most needed attributes inside a platform. if you think about checkout for e-commerce store, you would realize that I need to know in the checkout flow whether this product is sellable or not. Whether this product is sellable in what country, is the country that the customer is coming from, can I sell this product to the customer or not? These kind of attributes which are really core to a product and for the e-commerce store were called as core attributes. Core attributes are the ones that we really need to be imported in these platforms. For CMS, the core attributes really came out to 5 out of those 1,500. Right? So that means we were simply just over-processing imports with that MDM data model. 5 attributes are namely the name of the product, the description, the countries that the product can be sold, and that's pretty much it. And of course the ID. Right? All the rest of the 1,500 attributes could be fetched from somewhere else, helps me completely improve my performance of import by a factor of 5, and that's also conservative, not optimistic. Also helps me improve the internal publishing performance. Now, e-commerce store and CMSs, they all have some kind of internal publishing, where once they import, they have to publish that information to the customers. And that process is internal to these downstream applications. And that the change of not importing that whole catalog helped me improve the publishing performance by a factor of 7. Again, conservative, not optimistic. The core attributes are really something that the delivery apps like CXM platform and e-commerce store need. And we said, what do we need inside these applications is were really just the references. We also had another policy for when we started building integrations. The policy was called do not disturb. Again, it looks weird, but a policy that it works for at least us. Do not disturb is really a policy for downstream applications, which means they don't need to be disturbed of any updates that come from MDM. We talked about that these applications really need references of the product, not the product itself. So do they really need to be disturbed when you add marketing information on a product? Do they really need to be disturbed when you have more support content coming in? Do they really need to be disturbed when you're adding another image to a product? And the answer that we got was no. They don't need to be disturbed because they just need to know if the product exists or not. So we built this policy called do not disturb downstream application. And that means for any updates, we don't send any information to these applications. That helped us to convert the time to market speeds 4 times faster. We'll talk about the updated SLAs as well. But really, these applications are not receiving any data for updates. The first create that happens goes into these applications. Post that, they don't care. Right? Creates only, which means we only send creates to these applications, new product introductions. Completely new product portfolios go to these applications. We talked about M&As, merger and acquisitions. When that happens, we have new products getting introduced. That's when these applications will start receiving new products. Product line splits and mergers. Well, internally, business can take decisions about splitting a single product line into multiple product lines so that they can market them better, they can process their research and development pipelines better. For all those reasons, product line splits are also common. And for these scenarios is when these applications are going to get disturbed with new updates or new creates. Right? So we call this skinny integrations, which means that the product data model within eStore and CMS is really skinny. And we don't need the 1,500 attributes that we used to import. Data flexibility using data grid. We talked about skinny integrations with the downstream application, but how does in-memory data grid play a big role in this? How were we able to do that? How were we able to build that skinny integration? And part of the answer was using in-memory data grid systems. So we were using GridGain for building a data model which was completely normalized inside the data grid system, which will receive most of the attributes of the product. So we talked about those 1,500 attributes for each product. They all went to data grid, not the CMS, not the e-commerce store, but to the data grid. We started a concept called neighbor attributes. Neighbor attributes are really, everybody loves their neighbors, so neighbor attributes are really attributes that you need to build your customer experience, but you can live without them, just like your neighbors, right? You need them to build an experience for your community, but you can live without them while you're living inside your house. So we call them neighbor attributes. Those, if we take out 5 out of 1,500, rest of them all went to data grid. So data grid in the diagram saying, step aside, give me everything you got. That's how what we were able to achieve with that is attributes which are needed by the channel. The channel can be e-commerce store or the web, can be referred in real time. We'll make real-time calls from these applications to fetch that data from the data grid. Contains UI-only attributes, which means, as I said earlier, the core attributes that we talked about, which an e-commerce store really needs, like e-sellable flags, whether I can sell this product or not, those are the core attributes that are going to exist in the store, but rest of them are really information that you have to present to the customer. We call them UI attributes, customer experience attributes, and they can live in the data grid. Again, another use case for neighbor attributes. Neighbors live in data grid, and it contains omni-channel attributes, which doesn't need to be channel specific. Just like MDMs are omni-channel, data grid could be omni-channel. Data grid will serve your web, your store, your print, and your any other corresponding linked applications that you have, which needs those attributes. Now, well, you could ask about a basic question. Well, you were importing it in those 1,500 attributes in CXM. You were importing them in the e-commerce store. Now you're simply importing them in data grid. How does it really matter? Because these imports are really fast. So heavy attribution imports are done through streaming inside data grid. A set of 50 products take less than 30 seconds to get imported. Each product used to take 2 minutes on these major primary applications. Not just imports, because they had to also go through their internal publishing systems. CMS had to do internal publishing after imports. E-commerce store had to do its own publishing after imports. That used to take time for each and every product. And the CMS systems and e-commerce systems, they really want to know about all the dependencies of your products. They want to know which images are linked to the product. They want to know which documents are linked to the product. They also want to know all the other related information for your product. And if you don't provide that information to them, they're not going to let you publish that product. That's how these systems are built. But that's not a constraint for systems like data grid. That's why product teams doesn't need to build a fully fledged product before they can publish the product on the web. That was a hard requirement earlier. You have to have everything ready before you can publish your product to downstream. Now it's not, because they don't have to be 100% ready before they can take the product to the market. Of course, there's improvements that business have to do on their internal business processes to speed up things, but integrations help. It also means that because we're not doing internal publishing anymore for all these attributes, as soon as you import the data in the data grid, customers start seeing the data, right? Which also improves time to market. Now, do not disturb, how does that work with the data grid? Well, data grid is supposed to be disturbed every time there's an update or a create. So policy on the data grid side is, well, disturb it as soon as there's an update. Marketing updates on products, digital asset associations, support assets, and product enrichments, all of them pretty much go into data grid. And because the relationship with those assets are soft relationships, you can publish the products without having the product completely ready. All right, so that's how we helped our downstream applications to not import huge data. But how do we solve the problem of accessing normalized data? And how does in-memory data grid systems help us with solving access to denormalized data? Let's talk about the data grid design a little bit. The lower part of your screen, it talks about the caches which are completely normalized. So these are different caches that you see in the black. These are completely normalized caches. That's how we were able to make this integration work with the data grid, where even if the data model changes in MDM, there doesn't need to be a change on the data grid. If you think about products, sure, you need an entity of a cache, which is really a cache in the data grid. You need that entity cache to be there in the data grid. When you get new attributes, those new attributes automatically get imported in these data models that we build in the data grid. You don't need to change data models inside data grid after you build these normalized structures. So you got normalized structures like products, marketing, pods, classifications, digital objects, pretty much what we talked about when we were looking at the product catalog. We talked about all of these areas. These are entities. They need to exist as separate if you want to build flexible integrations. But that doesn't help my CMS system or doesn't help my e-commerce store to access them. Because like we discussed earlier, they have to pretty much access all of these 50 different normalized areas whenever they have to build a page, and that's not helpful. So how do we solve that? So we said, all right, we are going to call them as low-level caches. These are normalized caches that are built because we want to build a very flexible integration. And then we need a way to uplift them to something meaningful that my CMS and my e-commerce store can consume. So how do we uplift them? We use something called as computing grid inside the data grid system to amalgamate data from these different caches and build higher level caches, save them back into the data grid itself. So every few minutes when the data grid understands that there's a change which came from upstream systems like MDM, data grid triggers a compute job. That compute job runs very similar to Hadoop jobs, right, if you guys are familiar. And it starts computing all the changes that came in to my low-level caches. Those changes gets amalgamated, and we build new objects, and we call them higher-level caches. So the higher-level caches for CMS are really the content product caches. The store is store e-catalog caches. Every product that we have has a single object which lives in those higher-level caches. So what do my CMS has to do is has to ask for just one object. Has the information about all the relationship that it needs for the product. The product object higher-level cache will have relationship for videos, objects, support documentation, marketing material. Everything is part of that higher-level cache. And we couldn't have computed this outside of data grid. It helps to have a system like compute grid, which runs in-memory distributor jobs to amalgamate data from 50 lower-level caches and build simple higher-level caches, which can be simply consumed by a get operation from your CMS and e-commerce store. The response times for those caches are range between 37 milliseconds to 110 milliseconds. If you had to do the same query on the lower level caches, it takes about 4 to 5 seconds. Right? So it's a factor of what, 100? Easy. So that helps us to ensure that we're also building a flexible integration with my downstream so that MDM catalog changes, I don't have to change the low-level caches because they're completely normalized. But I amalgamate all my results that my downstream needs to build high-level caches, save them back in the data grid. All of these caches are persisted. They're all persisted. You restart your cluster, they remain there. And they can access the single objects that we build for them so that they don't have to compute that on the runtime when a customer request comes in. So that was helpful, having the ability of compute grip in-memory distributed systems, which creates multiple jobs, utilizes your grid to computing power to build higher level caches, save it back in the cache itself. Another thing that we wanted to utilize, but we weren't, were service grid. Service grid helps to expose services on top of your caches. We wanted to utilize it, but I think that was backlogged because of timeline challenges. But really, this is going to be our next steps. Want to build a microservices layer through service grid, which will help to expose these higher level caches or lower level caches to multiple applications, not only web and e-commerce too. So that's our next phase. Access from downstream apps, we talked about that. We talked about those caches and how we design the grid itself. But who's accessing it at this point of time? Really, the CMS and e-commerce store. They talk to the higher level caches directly. They talk to the CMS directly. So access pattern of CMS and e-commerce store, they really don't care about the MDM product catalog anymore. They used to. They used to have a need of understanding those 1,500 attributes, but they don't anymore, because that's all being dealt with by the low-level caches that we integrate with the MDM system. They don't need to know all those details anymore. That's hidden from them. That helps us to focus on experience, customer conversions online, rather than chasing down the MDM system data model changes every time we do a release. As soon as data changes, experience changes, because the compute grip helps us to trigger jobs which converts those changes on lower level caches and convert them to high level, so that we have an instant experience of our products on our product pages. Now, the performance on the compute grid, that's really striking when we started working on that. Performance was lightning quick. We had around 1,500 products changes that come in within 15 minutes. And the amount of time it takes to compute the high level caches was somewhere close to 1 minute. So within 1 minute, we were able to compute low-level caches, which were around 50, into simple objects that my CMS and e-commerce store can consume within a minute. So that was probably a game changer for us. Of course, this means that improved performance on my downstream application. The CMS pages used to take somewhere close to 5 to 6 seconds. And performance is completely improved because they don't have to bother calling their internal data models. They can simply access higher level caches from data grid. We talked about the pre-architecture change SLAs. The SLAs change. You would see that the metrics on the y-axis have changed from hours to minutes. So the marketing updates used to take a few hours, 5 to 6 hours. They changed from 5 to 10 minutes. Same with product enrichments and new product introductions and support material additions. So new product introductions, as I said, you still have to disturb the applications because it's a new product. It needs a reference of any new products that you publish from downstream applications. So that's why new product introductions still take around 30 minutes to get online. It's still a drastic improvement. We converted it from hours to minutes. So final architecture and integration after we put in the new systems. We integrated our MDM systems and ERP systems through a queue, and then we went through message brokers, ETLs, pushed them downstream to data grid, and also we only push skinny catalogs or skinny models to CMS and e-commerce stores. Rest of them goes to the flexible, low-level caches data model in the data grid. Right. Okay. Another use case for us was to figure out a way to deliver customer recommendations that we used to build on the web. So like every website, we monitor and track and analyze customers browsing through our site. And we try to understand how can we make sure that we can build a personalized experience by understanding what customer is interested in. So we had a way to generate recommendations for customers, whether those are product recommendations or part recommendations, but we didn't have a way to deliver them. In-memory data grid helped us to do that as well. So I'll quickly talk about the concept of the recommendation engine. Really, what's happening is you're collecting data for customers who are browsing your website, transacting on your website. So that's your collection phase. Then you're storing data somewhere. You're getting that big data in, storing that analytics somewhere so that you can do analysis on them later. Now, the analysis could be done by multiple machine learning systems, and we use one of them as well. But really, once you store that data, you have ability to fetch that data offline and process that data, analyze it, and then generate recommendations for the customer, which can then be served back to the customer itself. So it's a complete loop. You start tracking the customer from where they origin, where they start browsing your site, then you analyze that data, and then you bring recommendations, and you deliver recommendations back to them. It's a complete loop. That's the basic concept. We use a concept called collaborative filtering. That collaborative filtering is a basic approach for machine learning. You essentially build a matrix. So we build a matrix as well. The matrix, essentially, on the y-axis, you got users. On the x-axis, you got page views. We said, OK, you got n number of users on the y-axis, x number of users, x number of page views on the x-axis. Let's build a matrix. The checkboxes that you create helps us to build a recommendation for a customer. So customer 3 is really interested in item 4, right? That's what the matrix kind of talks about. Customer 2 is really interested in item 2 and 3. By analyzing this data in this matrix using machine learning algorithms and collaborative filtering, we were able to generate recommendations. And what that did eventually is it helped us to provide those product recommendations back to our customers. Now, how did we did it? We had a big problem of delivering these recommendations back to customers. That's where we used the data grid for. We had data grid serving these recommendations that came out of our machine learning algorithms. We host them on the grid. We serve those recommendations back to our website whenever users comes back. So these recommendations are generated in near real time, which means they have a lag of 4 to 7 hours. We're trying to improve that. But the delivery mechanism for fetching those recommendations in real time in a super quick way, DataGrid helped to do that. Of course, we had some on-premise services which were helping us deliver recommendations, but really there were the DataGrid which was implemented on cloud. That's where we were fetching most of our recommendations when a customer browsed through our website. All right. We had multiple learnings on the way. It was a bumpy road. It was not all fancy and dandy, right? Like every other implementation, this had problems. So I put down my thoughts on this, and I know I'm out of time, so I'm going to take another 1 minute. But I put down my thoughts for companies who are trying to explore this product. It is for companies who have internal dev and operations team who are able to manage your delivery capabilities. It's also for companies who are more hands-on on technology and who are more hands-on on integrations and building them themselves. It's also for companies who can do operations and monitoring outside of these core product itself. You have something like Dynatrace running outside. You can monitor your applications. Great. This product is for you. If you want to leverage fault-tolerant clusters for compute and data, you got to look at this product. It's really exciting. Data security is taken care of by your infrastructure. You don't rely on applications for data security. If that is one of you, then this product is for you. On the other hand, if you're looking for enterprise-grade security for the grid, you can still look for this product. It's great. You have to figure out a way on your infrastructure side to build security in the system. If you're looking for completely decoupled integrations, for example, we had issues with using REST APIs off the data grid. So that's how we make sure that we build decoupled systems. And there's still improvements that need to be made in that area. But if you're OK with going forward, integrating your systems with the data grid, that's great. It's a product for you. And you have a much bigger operations team that can handle the in-memory distributed computing systems, and they know how to work with them, then this product is really good for you. All right. Thank you, guys. If you have any questions, that's my email. My name is Apar Singh. Appreciate you coming over, and you have a good day.